right, everybody. Our next speaker is a desktop engineer at Slack and a maintainer of Electron, and will be giving us tips on how to make our Electron apps fast and snappy. Everybody put your hands together for Felix Rieseberg.
Thanks. Hey, good morning. My name is Felix, as introduced. I'm one of the people who builds the desktop app at Slack. And as maybe some of you know, we are using mostly JavaScript to build our app. And repeatedly, I think in the last year or two, people have talked about Electron as a pure JavaScript solution, which always bums me a little bit out, because everyone who's working on Electron is writing C++ all day long. And it's like very much a C++ tool. So I realized that we're at a JavaScript conference, but I'm going to be talking about C++ today. Jinx, sorry. So before we get started, let me briefly talk a little bit about why Electron in the first place. So Slack's mission has always been that we want to make people's lives a little bit better. And right now we think Slack is the best thing to do, but internally we sort of try to take the same approach, right? We want to make the life for our developers as comfortable and as easy as possible. We also want to make it joyful. How many people here write COM objects or used to write COM objects? We're in Seattle, so there must be some Microsoft people here. COM, yeah, DCOM, some of you. I have so far not met a single person who really enjoys writing anything in C++, right? Like nobody wakes up in the morning and is like, I'm going to build a hobby project and I'm going to use C++. I'm going to rewrite it all in C++ because I just like to, right? That has never happened in the same way that happens for other languages. When you talk about Node.js or Go or Rust, you will always have these people who really enjoy the language, and they're perfectly happy taking something that is currently working, but the code is garbage, and taking that to the language. That never happens for C++ or C, for that matter. So this is the Slack app. Maybe some of you have seen it. It basically looks mostly the same on all platforms. There are some important differences, and those are usually the native differences, but there are differences, something like the notifications. If you're using Windows, you will get a native Windows notification. If you're using Windows 7, it doesn't have a notification system. You will still get a native kind of fake HWND notification that is like a real native window. If you're on macOS, you get the native macOS notification. And if you're on Linux, we use something called libnotify. Again, to have the operating system display native notifications, which is something that Chromium, for instance, doesn't do, right? If you send a notification in Chromium, you get this little fake white window, but once you close Chromium, the operating system has no idea that that ever happened. And if you have something like the Action Center or Cortana or Siri or whatever, those notifications don't really cut it if you want to deeply integrate with the operating system. So let's talk about the life of a desktop engineer. I'm a staff desktop engineer. My team is 4 people big. Let's talk about all the platforms we ship for. So we have Windows 10, right? Wonderful platform. You have cool things available like UWP. You also have the Windows Store, which is not exactly the same, right? And never forget that you will always have a bunch of people who do not have access to the Windows Store or who simply don't care, right? As cool as the Windows Store is, you will always have these people who don't care about the Windows Store. They're like a giant IT corporation. They need to deploy your app a million times. They don't really want to go and open up the store and do the whole dance. And then you have Windows 7, an operating system that is still growing dramatically. And if I remember correctly, in January 2017, we could all celebrate that Windows 7 is now growing at a slower pace than Windows 10. Which is not to say that Windows 10 has overtaken Windows 7. It just means that today, there's more people buying Windows 10 than people are buying Windows 7 today. So if you're building any sort of software, you need to support that operating system, right? There's no way around it. You can either be not a company and broke in a month, or you can also have an app for Windows 7. Those are your 2 choices. And then you have macOS, where things are dramatically better, mostly because Apple takes this whole approach that they don't support anything that is older than 3 weeks, right? And if you have if you have a MacBook that is from winter 2016, you peasant, then then things are just straight up not supported, which makes it a lot easier for me because I can always just go and support the last 2 versions of macOS, and that is roughly fine because Apple will already shun away everyone else and apparently turn off their internet connection. But even here we have the Mac App Store, which is a slightly different programming model. You can't just take your app one-to-one and put it into the App Store. If you do cool things like Slack is trying to do, right? We do more than just chat. We have like screen sharing, video calls. You have to live in the sandbox. So this is like a different world for you too. And then Linux, which is of course a giant desktop tire fire, and nobody really knows what platform to release for or which. I had a call the other day with Ubuntu. It told me that they have now figured out that maybe they should have one delivery in binary format for all operating systems. And I was like really excited to learn that there's a competing standard, of course. It's like the Red Hat standard and the Debian standard. I'm like, this is the same thing we already had before. It's just like, there's now 4 standards except of 2, just great. So whatever you do, these are the platforms you support, right? So if you don't do anything cross-platforming to begin with, you need a team for each of these. And if you're a company like Slack, you can be really generous and maybe think that like each of those platforms deserves at least 2 people. We have a Windows Phone app. That team has 2 people, right? So if you think about something like Windows or macOS, they probably deserve a little bit more than our Windows Phone app does in resources. So immediately you have like a team of like 60 people just sitting there, which is hard to maintain and finance. That is just straight up difficult, right? But Slack is also one of those apps that solved the solution with JavaScript. And yes, that is the direction I get every single time I talk about desktop apps in JavaScript, that people from like all camps are a little bit like, why would you though? And the response I always give is that desktop apps in JavaScript is a little bit like CGI. There is so much that you probably don't notice because if it's done well, you don't notice. We're all JavaScript developers here. If you have anything made by Adobe, the moment you launch it, you're running Node.js. Photoshop runs Node.js. If you have a Windows machine or you have an NVIDIA driver, you're running Node.js because that's how NVIDIA does web stuff. So it's like very hard to find a machine today that is not already running some form of JavaScript on the desktop anyway, right? And that is just the low level. There's like the poster childs of JavaScript on the desktop, Spotify, Visual Studio Code, Atom, all the big ones, right? This is just one of the many apps built with Electron, but there's a ton of them, right? The trouble though is, and I think that's an actual real trouble, is that every single time we go out and talk about Electron, what we try to tell people is that this is a cool way for you to build 90% of your app cross-platform, which is more than what most platforms can offer, right? And then people look at me, look at my demo, go home, take their website, wrap it in a container, and are like, done. And then you end up with all these apps that are, dramatically slower than other apps, but people notice, and then people start attributing the slowness of that application to Electron as a platform and JavaScript on the desktop as an entirety, which I think is unfair. There's a bunch of apps out there that could be dramatically faster, and Slack is like one of the ones that could be dramatically faster. We're as a company now 3 years old, and we're now rewriting the whole app from the ground up for the 3rd time. We're getting really good at it. So, if you have Slack open in front of you right now and you feel like, well, gee, Felix is standing up there talking about fast desktop apps, but this app is not as fast as it could be, you're right. It is not as fast as it could be. And this is the same for like virtually any other app, right? Atom has just released a new version that implements a native text buffer. And that is sort of also my first go-to example. Let's take a quick peek at what Electron actually is. So there's 3 components. The first one is Node.js. That is the thing that hopefully everybody in this room sort of likes. If you don't like Node.js, then what are you doing here? But hopefully you like Node.js, right? Then the second component is libchromium content, which is the rendering engine of Chrome. There was like a big blog post about how Electron sucks because it ships all of Chrome, and I was like, it doesn't though. Which was a blog post about like all the drivers Chrome contains, and that Electron also contains those drivers. I'm like, but it doesn't contain any other drivers. It's open source, you could have checked that out. Anyway, it's libchromium content, which is just the rendering engine, but also naturally V8. We use in Electron the V8 that comes with Chromium, not with Node.js, which gives us a slightly more recent version of V8, which is wicked fast. It is so crazy fast. if you ever try to do anything in JavaScript and try as hard as you can to make it fast, which most of us don't do, right? Like let's just be honest, most of us just import 20 libraries and then call it a day. But if you try really hard, V8, and you write your code a little bit like C, V8 is so wicked fast. My favorite example of that is regex these days, because you can, it's almost Turing complete. You can do pretty much whatever you want in regex. And V8 just takes that straight down to assembly. I have like one giant regex class that is like 10,000 lines that just tests for all kinds of different characters, because Slack works with humans, and humans tend to have many characters available to them, right? So my regex classes are pretty big. And I really thought about like crazy ways to make this like not slow. Like before I started actually working, I was like, maybe I can make a web worker and put this in a thread, and then I did a benchmark, and like my MacBook, which in all fairness is pretty fast, but my MacBook was like, I can run this 3 million times a millisecond. I was like, okay, well, I guess it's good enough. I don't really. Just the overhead of like spinning up a web worker, right, would have been so much slower. So libchromium content V8 pretty fast if you really wanted to. And then there is C++, which most people don't want to use in my intro. I don't want to use C++. I'm terrible at it. I'm a JavaScript person by heart. I don't really know C++. I just keep writing it, and when it compiles, I'm like, guess I'm going to ship this. But yeah, so what Electron does, with the help of people, to give you some peace, with the help of people who actually do know C++, I'm just like also in the room, like, not knowing anything. We take C++ and put a thick, big wrapper around Node and Chromium that allows you to call all these native APIs natively. So for instance, for the notifications, I made modules that you can use from Node for both macOS and Windows to send native notifications, but you don't need those modules anymore because we just put that in Electron core. And if you send a notification from Electron, what happens is that we go into C++ and it's doing the same thing you would do in a native application. And naturally, if you extend this train of thought, you could do the same thing for anything that you have, right? And there's a few really famous examples. And I think if I just go and do that real quick, you may have noticed if you, well, that was a bad search. You may have noticed if you use GitHub's Atom a while ago, that it wasn't as fast as maybe it could be, right? Generally speaking. Atom, not the fastest editor of all times. And the solution to that took a while, but it's also glaringly obvious. It is to just like handle everything that is text-related natively in C++, right? And now Atom is wicked fast, which is sort of an obvious solution. And the reason it wasn't done before is because now the code looks like this, which is, kind of disgusting because we as JavaScript people are not really used to the idea of managing memory ourselves, right? And like having to worry about garbage collection. And there's like a whole lot of things in JavaScript that are really nice that you have completely forgotten about because you've been using JavaScript forever. And then you go back to like a CLang and nothing really is nice, right? If any of you ever use like macOS NSLog, it's terrible. Like, you can't just log a variable. You gotta know what the variable is, what type it is, and then you gotta cast it, and you gotta cast it again, and just like all kinds of casting is going on. But the result is that if you use Atom today, it still uses HTML and CSS and all the goodness to like display the user interface in a cross-platform manner. And browsers have gotten extremely good at doing that well, right? There's a few other platforms out there that have the same claim to fame. There's maybe Qt. Java is getting close, but the web might be the best thing that we have if you want to display, let's say, video. Playing a video like an MP4, right? Not even like an old video, but you want to display like an MP4 and you want to display that on all platforms. That is a pretty tough task. It's a lot harder than you might think it is. But the web makes that very easy because we've been doing that as a community for a while. So now using the web, that just works. So what we do in Atom here is that the user interface and everything you see is still implemented in HTML and JavaScript and CSS. And it's easy for the developers to work with, right, to add some features. It's pretty straightforward. You don't really have to do extensive testing. You can use everything they ever wanted to. But you can also manage the text itself in a native module in C++, which allows you to easily open up a text file that is 4 gigabytes big, right, which some time ago, Atom would just like be like, no, I can't. Just straight up say no. And you see the same thread happening in more and more Electron apps. Visual Studio Code search, blazingly fast. The Electron source repository is pretty big. It's thousands of files because it does include libchromium content, right? But Visual Studio Code just searches that thing like crazy. It just doesn't really care. And naturally, the solution, again, is C++. It just like shells out and tries to use native components to do the same work. So going back to this, let's look a little bit like how Electron works internally and what actually happens when you start an Electron application. So the first thing that happens is that there's an invisible main process which behaves exactly like a node process. If you start an Electron application, there's no window, there's no nothing, there's just this main process. And it behaves exactly like a node process. You can require a native node module if you want to. If you have something like SQLite, you can just npm install that. npm will use Node.jib to compile it for your platform. If your platform is like a common platform, we'll use pre-jib to find a binary that somebody else has already compiled for you. And then you have that native .node file that you can import using bindings. You can just require it, running the native version of SQLite or bcrypt or whatever you need. That process now has the power to spin up other processes, which is kind of cool, right? It has the power to spin up a renderer process. There's always just one main process, but there will always be at least one renderer process if you want to display anything to the user. The renderer process comes with a window, right? It has a window that has a window object, it has a document object model, but in that window we still have Node, which is kind of cool. We still have Node in that thing available, which I'm going to show in a minute. But we also now have libchromium content in there with the ability to play videos, with the ability to do all those like user interface things that we used to. But the cool thing is that this renderer process has obviously more power than you as a web developer get. This is not the same thing. Like if you want your window to be half transparent and have like a weird shape and be somehow magically on top of the dock or on top of the taskbar, this is all available to you because essentially we control how this window is instantiated. And if you make a nice PR that does something dumb to a window, we will probably accept it, right? There's like all kinds of things you can do now. We, for instance, had a need to overlay a giant red bar all around your screen, right? Which is not that easy to do if you think about it, because around your screen are things that normally take precedence over anything else. There is the menu bar on the Mac on top, there's the dock on the bottom, and if you ever tried, you can't really pull a window on top of the dock. But natively, you can do pretty much whatever, right? So now we can do that. You can just tell Electron, hey, this window doesn't respect anything. It's now on top of everything else. Not just all the other windows, but like everything else. And then those two processes can talk to each other. There's something called the IPC module, which is coming out of the Chrome world, which is how Chrome maintains the communication between its main process and each individual tab and window. And you can basically use that IPC to send objects and messages back and forth, right? That is something that's totally available to you. So here's what you can do now. You spin up many of these processes, as many as you need, because processes are really lightweight. And we have learned quite a while ago, when Chrome came to the world a bunch of eons ago, that multiple processes are a good idea in general, right? If you have the ability to spin up your work into multiple processes and gain some benefits, operating systems are really good. I mean, they're okay. They're okay at running processes for the most part. They're pretty good at it, right? That's really what they do. So using this IPC, what you can do now in your Electron application is you can just use a bunch of windows that are completely invisible, don't have anything in them, don't even like instantiate the window, you need nothing, require just one native node module, and then use the IPC to send objects back and forth, which is really powerful, right? Common example is my favorite example is there's an email client called Nihilus. That's a bad screenshot, but looks roughly like this. I mean, it looks like an email client. There's really not much to say about this. There we go. It is a normal email client. It looks exactly like you would an email client expect to look, except that's an Electron application. And if any of you have ever tried to do some text analysis in JavaScript, that is pretty slow. If you can't express it in regex, JavaScript is pretty slow. It can't really optimize that. If you do like an index off, and you want to do that over like a bazillion files, that's going to take a while. so what Nihilus does, it has always an invisible window running in the background, which is really just me faking the name for an invisible renderer process in the background that is using SQLite. Then it puts something on top called RxJS. Does anybody here use RxJS? A few people. For those of you who don't, it's just like one of those libraries that turns your stuff into like monads, basically. Sorry, all the RxJS people will be like, no, that's wrong. But yeah. So basically, they have SQLite running an invisible window, and now whenever you do a full text search, they just shell that out to SQL, turn that into a SQL statement. It's being run natively in SQLite. SQLite, despite the name Lite, I don't know who gave this thing the Lite name, because if you look at the limits of it, it's gigantic. Like, it can hold billions of records. It's totally fine. So full text search in Nihilus is now extremely cheap. It's fast. It's still cross-platform, because SQLite was already written in cross-platform way. Node bindings are cross-platform anyway. And all the interfaces you write, you still write those in HTML and CSS and JavaScript. It's no biggie, right? You basically use the IPC to spin up processes to do cool stuff. And we at Slack do the same thing. We do that for video calls, right? So whenever you start a video call in Slack, we don't, whatever solution you would have pre-WebRTC for video calls, we don't do any of that, because that would be terrible and slow. Right? We have something that we internally call call score. It is a beast because it contains all of RTC. It takes about we install it with NPM actually, which is probably a bad idea because it's like gigabytes big, the source code. But our video calls, we just NPM install it, then our computer completely shuts down for 30 minutes and compiles this beast. But once it reaches your machine in the compiled Slack version, it is blazingly fast. Right? Nobody has ever complained that Slack video calls slow down the machine, because they don't, because they're extremely lightweight compared to how you would implement this in JavaScript. But at the same time, opening up this window, closing this window, anything that involves this call is still something that a junior engineer coming from bootcamp can easily work with, because the methods that are behind the Slack calls thing look just like normal JavaScript methods. They're just bindings, right? There's like a make a call method, and this thing you just call with the same way you would call anything else. The same way you would use bcrypt in Node, or you would use SQLite in Node. Okay, so this is basically the lesson, right? If it's extremely difficult, we do it in Objective-C and C++. And I don't really know how much time I have. How much time do I have left? Plenty. Plenty? Cool. Yep. Neat, because that would allow me to do a little bit of a demo, which is nice, to just basically make the pitch for Electron and why Electron is cool. Okay. So what I'm going to do is I'm basically just going to quickly build Visual Studio Code, and then we will see whether or not we can add some native node modules. So, okay. So what I'm going to do here, I'm just going to instantiate this, right? This is good enough. And then I'm going to install Electron as a dependency, because any Electron application is fundamentally an NPM module, which I think is pretty cool, right? Okay. Wi-Fi. Let me just open this up while we do this, so we can start writing some code. Okay. Cool. So far we just have this package.json, right? It has a main file, index.js. And normally I would just make this and say console log, I would say something cool as hi, right? If I now go and run this, actually, before I do that, let me add the good old npm start. Okay. I'm not going to call it server.js. Come on. Okay, so. Cool. So now, I don't know if this is big enough. If we just run this, it's going to do the expected thing, right? It's pretty boring. So how to turn that into an Electron application? It is so dead easy. That is it. And if we do the same thing, We can still start it, we can still run it, it does the same thing. With one exception, it doesn't exit, because Node, as soon as all the code is done, it like exits. An application usually would wait for some instruction from the operating system, maybe opening a file or whatever. So we only exit when you actually tell Electron to. But now, one thing we can do that we can't do in normal Node is we can just go ahead and require the application and maybe a browser window. And then we can wait for the application to be ready and just make ourselves a new window. There we go. So if I start this again, we now actually have opened up a window, which is pretty cool. That is how you would do user interfaces. That is how you would do stuff. And this is already a normal libchromium content window. It even has DevTools, which immediately crash because a window is assumed to have content. This one doesn't. So DevTools is like, show me your HTML. Oh, you don't have any? Cool, I'm going to crash. So what we're going to do is we're going to make an index.html just so that we have anything, right? And we're going to just, yeah, no, this is fine. We don't need anything more. Yeah, good enough. And then in here, say main window, load URL, file, index.html. So if we run this application again, now, I mean, obviously this is an empty page, but the DevTools don't crash anymore because we actually have stuff here now. And the cool thing about this is now, if I go ahead and just do this, that totally works, right? There you go. You have like full Node available in your window. So that's basically the basics of Electron, right? And now you combine that with something that was already written in HTML, in the web, to be cross-platform. So what happened at Microsoft was that somebody at some point wrote a thing called the Monaco editor. Looks like this. And then somebody else at Microsoft was like, we should package that up and sell it. And someone else was like, you're joking, but I'm going to do it. Right? This is already exactly the same thing that you would expect in Visual Studio Code. This is like very, very close. So in order to turn your application into Visual Studio Code, what we're going to do is, before I actually do anything else, let's beef this up a little. Let's add a container here. Okay. So because this is just Node, essentially, I can do this. Right? And now I have a renderer file. And in here, I can once again just say hi. Cool. The style sheet. Yeah, we should probably add some styles. Which I think I've already prepared. Yeah. Pretty boring style sheet, basically just saying I don't want any margins, because margins make sense for documents, but they don't make sense for applications. Obvious reasons. OK, so now that we have that, I can run that as a quick proof. Right? We're now logging things from this renderer process. So anyway, because this is Node, I can pretty much use whatever I want from NPM. It just works. So for instance, this Monaco loader. Cool. And then in my renderer.js, I can just say const loader equals require Monaco loader. Yeah. There we go. Cool. So I actually got to load Monaco, though. This is just what that does. So what we have here, a Monaco loader is just a module that loads Monaco. Monaco is this editor, right? And once Monaco has been loaded, you can use it. And in this case, we're just creating a new editor. Pretty straightforward stuff, right? So if we start this again, oh God. If we start this again, maybe things will actually work. There we go. This is now a fully working JavaScript editor, right? Which is And it even has like IntelliSense and all the stuff that you're used to from Visual Studio Code. It's basically the same thing, right? It's like, that took like, what, 5 minutes? Oh, I have 2 minutes left? OK, sweet. Yeah. So the obvious thing that makes this now interesting, and this is really the gist of this talk, this is the gap between a slow Electron app and a fast Electron app, is that whenever you're working on this renderer.js file, and you have the choice between const a equals require my super slow and bad JavaScript or my super fast C++ module, you should do the latter, right? That's really the gist of it here. The gist of it is that Electron is a really, really cool tool to couple C++ with your website. That's the point of Electron. That's really what's cool about it. There's a lot of C++ already in Electron, but you can write your own. So every single time you see a slow Electron app, you can join me in saying, your app is slow, and it's your fault, and not Electron's. Right? Because that's, to someone, I'm really excited about Electron. It's always heartbreaking to me if I see like developers being like, yeah, my app is super slow, but Electron. I'm like, no, it's you. You wrote the slow code. That's why it's slow. Yeah. So that's really the moral of this talk. I'm going to use my very last second to point this out. I will always gladly answer any questions on Twitter or on GitHub. If you want to see any examples for simple little native modules for all the platforms, because that is something that is fairly new, right? You can just go to my GitHub. I have little examples for native module for Mac, Windows, all of them. I'm also going to be around for a while if you have any questions. Anyway, thank you very much.